Hello everyone, I'm Dia from 4BSCDS. Welcome to my CAC Component 2 presentation for the subject NoSQL. Today we are going to delve into the fascinating world of NoSQL databases, exploring their features, understanding their significance, and finally building a fully functioning web application using Flask and MongoDB. Let's start with the basics. NoSQL databases, or not only SQL, are a type of database management system that diverge from the traditional relational database model. Unlike SQL databases, which are rigidly structured and require predefined schemas, NoSQL databases offer more flexibility and scalability, making them ideal for handling large volumes of unstructured or semi structured data. For example, consider a social media platform like Facebook or Twitter. These platforms generate massive amounts of data every second, including user posts, comments, likes, and so much more. Storing and managing a database efficiently requires that can adapt to the dynamic nature of social interactions, which is where NoSQL databases shine. Now, types of NoSQL databases. First is document based. MongoDB is a prime example of a document based NoSQL database. In this model, data is stored in flexible JSON like documents, allowing for easy storage and retrieval of complex data structures. Second is key value stores. Redis and Amazon DynamoDB fall into this category, where data is stored as simple key value pairs, making them ideal for caching and real time applications. Third is column family stores. Apache Cassandra is a well known column family NoSQL database optimized for handling large amounts of data across distributed clusters. Fourth is graph databases. Neo4j is a leading graph database designed to represent and query complex relationships between data entities. Now let's dive into building our web application using Flask and MongoDB. Flask is a lightweight web framework for Python, while MongoDB serves as a NoSQL database backend. Our application will be a simple clothing inventory system, allowing users to add, update, and delete clothing items. Let's walk through the code to understand how it works. Firstly, we set up our Flask applications and connect to our MongoDB database using the PyMongo library. We define routes for displaying the inventory, adding new items, updating existing items, and deleting items. Then we move on and create our HTML templates. The HTML templates that I have created in my clothing inventory app are as follows. Firstly, I created index.html, second is create, third is insert, fourth is update, and lastly it's delete.html. So in our HTML templates, we use Jinja templating to dynamically render data from our MongoDB database. For example, in our index.html template, we loop through each clothing item and display its name, price, description, and an associated image. Now let's discuss the crude operations that we have performed. Firstly, it's create. We use the post method to add new clothing items to our database. Users can input the item's name, price, description, and upload an image. Read. The index root displays all existing clothing items in our inventory, along with their details and images. Update. Users can edit the details of a clothing item by clicking the edit button, which redirects them to a form pre filled with the item's current information. Now, delete. Clicking the delete button removes the corresponding item from our database, updating the inventory accordingly. Now, implementing the clothing inventory system. Firstly, it's Flask routes and templates. The web application's core functionality is implemented through the Flask routes. which handles user requests and interact with the MongoDB database. Secondly, it's data storage and retrieval. The PyMongo library is used to establish a connection between Flask and MongoDB, allowing for efficient data storage, querying, and manipulation within the application. Third is image management, and fourth is error handling and validations. Now, coming to the benefits of using NoSQL with Flask. Firstly, NoSQL databases such as MongoDB they offer a flexible schema design, allowing better adaptation to changing data requirements. Second, its scalability. NoSQL databases are highly scalable, both vertically and horizontally. Third is performance. The document based structure of MongoDB and its optimized querying capabilities often result in improved performance. Fourth, last but not the least, is developer productivity. The combination of Flask's simplicity and MongoDB's flexible data model enhances developer productivity, allowing them to focus on building the application's core functionality in a better way. Now, for conclusion, NoSQL databases offer a powerful alternative and to traditional SQL databases, providing flexibility, scalability, and performance for modern applications. By combining Flask and MongoDB, we can build robust web applications capable of handling diverse data requirements. Thank you for joining me on this journey through NoSQL and web development. I hope you have gained valuable insights into building applications. Thank you.